Thank you very much. Hello, everyone. My name is Duy Nong, and I work at for agriculture and food at CSIRO in Australia. And I also an adjunct associate professor at the Center for Applied Energy Economics and Policy Research at Griffith University in Australia. And today I'm very happy to share our recent work with our colleagues at CSIRO about the research topics is about the two-step approach towards sustainability in West Asia, contributing to tackling global climate change. And so in this study, instead of looking at the technical engineering uh, compared to the previous lecture, today I would like to show you the on the economic aspect, how the policy will affect the material flow and material demand. And there are four sections in the presentation today. First of all, I will talk about the introduction and then the methodology and modeling result. Finally, I will provide some highlight about the concluding remarks. There are some common knowledge and information that we all know in recent years or recent decades about the environmental and social program in many cities and countries in different regions around the world. And for example, like we are increasingly experiencing land degradation, air and water pollution, biodiversity loss in many different regions around the world. And so what are the sources of the problem? It's because we can see that the population increase very quick, and also we are also experiencing the economic growth in many different countries, especially in developing countries like in China, in Asia, in China, in Indonesia, in Southeast Asia, also in America. So with the population and economic growth, this also increase the demand for commodity, for material, such as for food and also for fossil fuel, for energies, and also for like some material in the construction sector. So in terms of the fossil fuel demand, it's also, we know that it releases a lot of greenhouse gas emission and called the global warming and climate change issues. And the greenhouse gas emissions come from many different sources. For example, come from the fossil fuel combustion when we burn energy, burn coal or petrol when we ride a vehicle. This also emission, greenhouse gas emission also come from the land use when we convert forest land to the croplands, and also some agricultural production when we raise the animal, and emission come from the fertilizer and livestock capital. And it also comes from the exploitation of the and transportation of the fossil fuel, and many different production activities also release some kind of greenhouse gas emission. And with economic and population growth, and we also see that in many different cities around the world, especially in developing countries, in Asia and in Africa, and many countries have the unsustainable production and consumption framework. Like with current technology in this city or in this country, mainly they use the resource effectively and efficiently, and also we experience the poor waste management, like food waste, and we dump a lot of plastic bags into the environment, into river and into the marine system. So we can easily see in the media that the marine pollution with a lot of plastic bag and rubber. And so all of these things here it relate to materials. And so what are the material we are considered in our study in this study? I can say that this would refer to all things that we can see and we can touch. For example, like fossil fuel, coal, crude oil, natural gas, etc. And also agricultural products and residual like salt, meat, fish, wheat, plants, straw, even some residue. So you can see, and also the mineral like gold, copper, nickel, iron, etc. And so it refers to a lot of things, the primary material that we dig out from the ground or we blend in our culture sector technologies. And so it's come up to an important question. So because it with everything, the climate change issues and um, environmental problem, it related to material. So so we know that's why tracking and controlling material demand are very important to tackle climate change on a global scale. First of all, it uh, I think most resources are not renewable. For example, like fossil fuel and mineral, we burn coal and we lose permanently. And so, in this case, if we can control and reduce the material demand, we can have the resources for our future generation, our children, grandchildren, and great grandchildren. So we want to reserve that for them and to have the adequate resources for their development. And also, if we control the material demand like the fossil fuel, we can help to reduce greenhouse gas emission released into the atmosphere and to mitigate the climate change impacts. So that is that will be very good for our environment. And when we consume less commodities and release less waste into the environment, this also reduce the waste management pressure in many different cities like in India, China, Vietnam, Philippines, and other developing countries in South Africa, uh, South America, and Africa. And when we consume less food, it's also good for the agricultural sector because it's reduce pressure on land and water resources because these resources are limited. So if we can consume less food for the current population or even growing population in the future, I think it will be very good for the natural resources. And it's with less commodity consumption, it also helps to improve environmental conditions like air and water qualities. And when we use the commodity more effectively and efficiently, this also helps us to reduce the price of commodities, so help to reduce the cost of living and improve the human well-being. And here I would like to share with you some facts about the material demand on a global scale. For example, the global material demand increased significantly from 27 billion tons in 1970 to 92 billion tons in 2017. So at the same time, global material demand per capita also increased significantly from 7.4 ton to landing region in Asia, particularly in West Asia and the Pacific, with annual growth rate by 3.4% to 4.5%. And also, the, we can observe that the emission related to material in just 20 years from 1995 to 2015. And in 1995, it's only account for 15% of global emission, but increased to about 23% of global emission in 2015. And in this study, we focus our study on West Asia. So why the West Asia play a key role in contributing to tackle climate change issue on a global scale? Because West Asia is the world's largest oil and gas resource reserve, and it also is one of the world's largest oil and gas producer and exporter region countries. And main revenues and oil and of this country come from oil and gas production. And with a lot of revenue comes from the oil sector, it's also experienced fast economic growth rates and to uh, increase the infrastructure and construction demand development. So if we so the question here is if we can control the resource extraction and material demand or even facilitate the sustainable consumption and production in the region. So what we mean to the global environment and international efforts to tackle climate change issue. This is the important question that the United Nations want to know, and we also have the order for us to conduct this study and to provide also for the international resource panel in the forthcoming global resource outlook in 2022. So previously, no study had been conducting to study the impact of policy on the material flow and material demand in individual country in West Asia. So our objective here is to study the economic impact of three different policy options. The first option is we try to look at the impact of the resource efficiency policy, and we assume that there are gradual improvement in output productivity of key material producing sectors like fossil fuel, iron and steel manufacturing, chemical, etc. And we also assume the gradual improvement in productivity in using key material by all industry. So actually the output productivity and input productivities are just two sides of a coin, but because we collect the data and the resources from other study, so it depends on the data available. So and it's also they focus on different industry. So in here we select the shop and we select the information to incorporate in our study. The productivity here is mean that we can use less input to produce the same amount of output, or with the same input we can produce more amount of output. And for this policy package, we also assume gradual increases in production cost for mining and primary material producing sector. The purpose is behind this to reduce the supply of the material to the economies. And also for this policy scenario, we also assume some consumer behavior, like we import the direct negative shock to demand for material. We just assume that, for example, like people perceive that they can consume less commodity to protect the environment. So they aware that if they consume more and produce more waste to the environment, it will be not good for the environment, living environment. So we assume that they try to consume as less as they can. So in this study, and we collected all of the short, all of the information from the literature and also from our previous study. And in the second scenario, we focus on the climate change mitigation policy. That we assume the implementation of the global carbon tax. When we have the tax on emission, this will reduce the incentive for the industry, for household to use less fossil fuel and to reduce less emission. And we also assume gradual improvement in the producing electricity from bioenergy and carbon capture storage technology. That's the development of the carbon dioxide removal technology. And also we assume the gradual improvement in using land to make land more productive for agriculture sector. And in the third scenario, we call it the towards sustainability policy. Thus, we combine the scenario one and scenario two to have the less emission, but also achieve the economic growth rate like increase in real GDP. And because the shop and the values are abundant for the many different countries and many different industry. So I not show it here, but if you are into our research and want to know more about the shop that we put in the model, please contact me. I'm very happy to share this with you. And I also would like to note that the shop we collect here are different across across country and also in different periods also are different. And for the presentation today, I would like to show you some results just related to the economy's activity like the real GDP, also the emission level and material demand, material productivity like real GDP per material input. And for this study, we employ the Z10 resources model, global trade and environment model resources developed at Silo in collaboration with the Australian government ABS. And the main feature of the model is the maybe you have heard about the city model and Z10 resources is also a recursive dynamic global computable general equilibrium model. Just imagine that we try to bring the real world every economic activity into the global. So the general feature of the model is that it includes almost all sectors in an economy that you can see, for example, household, the government, industries, investor, exporter, and importer. In the model, we don't talk about the individual like person one, person two, or firm A or firm B, but we model the household as a representative and representative government and industry in aggregate. So we just remember that we don't talk about the individual company. And for industry, as you can see in the reality that they produce the goods and services and the demand for inputs like labor, capital, material, some material, and also land for our agriculture sector. And they pay salary for employees and pay tax for the commodity they consume. And also for household, they also supply labor to the company, to the industry, and they receive the income. And they also pay the income and consumption taxes. And the saving equal the income minus expenditure. And the government also have the revenues from the tax revenue, and they also consume goods and services, and they provide a subsidy to household and company industry. For example, during the COVID pandemic, many governments around the world already provide subsidy to household, many different household groups and to companies, especially the services and manufacturing companies. And in the model, we all these activity and behavior follow the economic theories. Thus, we assume that, for example, like industry, they try to minimize their production costs, and consumer household, they try to maximize their utility. That is the satisfaction. They try to maximize the satisfaction. And in this figure, I would like to show you how a CG model and especially if you can resource model work. We have the household government, labor markets and commodity markets, and they all link together. And the country, for example, can link via commodity markets. You know that we import a lot of commodity, apple, orange from other country, and we export clothes to other countries as well. So it linked through the commodity market and also the labor markets and investment. Also, we also put this thing in the CG model, in detailed resource model. In this figure, I would like to show you some basic structure of the non-technology bundle industry. We call this one because we try to separate it from the technology bundle industry. That later in the next slide I will show you. Here in this figure we can see the output on the top, and the industry can demand for many different inputs, like in different inputs for in their production processes. And in this layer you can see that they have the coal, gas, petroleum, and electricity. This commodity in the same level like this can be substituted for each other. For example, when the price of coal increase significantly compared to gas, and petroleum products. An industry can use more gas and petrol instead of coal to reduce their production costs. This also happens the same logic for land, labor, capital, and natural resources. And for the technology bundle industry, the structure is a little bit different. In in the model, we have three different technology bundle industry. We call it the electricity. It has 15 technology come from the fossil fire power station to to renewable uh, power station and also the nuclear power. And steel manufacturing also have two technology, and then transportation also we divide into five technology. The structure here is different is because each technology can substitute for each other. For example, the electricity derived from coal fire can be substituted for electricity from wind or solar. But for each technology, it uses specific input. For example, coal fire power station, maybe they have the unit capital and factory and labor. That is just for the just for the coal fire technology station. If they shut down, for example, like coal fire station, they cannot move the capital factory to produce the electricity from wind or solar. And also labor working for the coal fire station. If if the shutdown, they have to go through the heavy training to become familiar with the technology to produce electricity from wind and solar. So in this way, we try to separate the specific inputs for different technology. So how the result look like in the CG model? In the CG model, in the weekend resources, we have the baseline like this, and we project the country economy to, for example, from 2020 or to 2050. And the baseline is we have the no target policy shock, business as usual, so the economy just grow as usual. And in the policy scenario, we have uh, the tax policy in place. So if we drive the economy to another pathway, and we can look at the deviation between the policy and the baseline. So that is the result. And the result is we can look at many different variables like GDP, price index, output, or input. And for example, we can know that the real GDP will reduce by 2% in 2030 compared to the baseline. And you can look at the result in particular years like 2025 or 2050. So in the model data, we use the global trade analysis project database supplied by Purdue University in the US. The years in 2014. The reason is we had a lot of some year lapse in database here because we collect data for example, from 141 countries and 65 industry. It's, it's a major job, and so it takes time. So that's why it will have some year lapse in the database. And in the database also have the greenhouse gas emission like carbon dioxide, methane, nitrous oxide, and gases. And the units in the data is the US dollar because if we talk about the monetary flow, and for the greenhouse gas emission, we have the million tons. So how in this slide, I would like to show you how we link the model data with the physical material flow or material demand. We try to index the dollar value of commodity flow in the model. So we know that the value is equal to quantity times price. And so the values also, we have the input value, QI, and also output value, QO. And we put in the model that percentage change or trend in the input for quantity is equal to the input for material in physical units. And also the same logic we apply for the output. Percentage change or trends in output in quantity also similar to the percentage change or trends in the output for material in physical units. And we collect the primary material from many different sources, and there are over 200 kinds of categories of material. But in this way, we just group them into some main material group and to map with our GCAM data and industry like the crop sector with crop, fish and with agriculture and harvesting, and coal mining with coal, something like that. And for the data, we also aggregate them into 26 industrial sector, including some primary material sector like crop, animal, forestry, or fishing, or coal mining. And for the country region, we group them into 40 country regions, including the main countries in West Asia, like Saudi Arabia, Bahrain, Jordan, Kuwait, Oman, and Qatar, and UAE. For the baseline scenario, we project the baseline that you can see like this. This including the population growth and economic growth rate following the social economic pathway to the middle of the road and also the emission level. And we also assume the technology development, energy demand, and land productivity. We collect this data from many different sources and in the literature from the report of the United States also and from the research by many different entities. And for three alternative scenario, as I described previously, we look at the impact of resource efficiency policy, climate mitigation policy, and a combination of to make a true sustainability scenario. And our study period is in 2015 to 2016. So again, if you are keen to see the detail of the shop that we put in the model and also the information, please contact me. So I'm very happy to share with you. So here I would like to show you some modeling results. First of all, I would like to show you some result related in the baseline scenario. Here is the baseline scenario material extraction by different countries in West Asia in from 2015 to 2016. And you can see that Saudi Arabia and Oman also increased significantly the demand for and also the extraction for material. We refer the material extraction here in aggregate level like coal, goods, oil, mineral, everything crop, all of them combined together and measure in million tons. And also here's with the baseline, the result in the material extraction by material categories, biomass, fossil fuel, metals, and non-metallic mineral. So non-metallic mineral is related to something like the rock used in the construction sector. So you can see that the West Asia country try to maintain the production level of the fossil fuel and also the biomass, but for metals and non-metallic mineral, they increase significantly because population growth and also increase of the infrastructure to develop their economies. And with massive material extraction, the region also experienced rapid increasing in the greenhouse gas emission. For example, this increase for many different countries like Oman and Kuwait. Saudi Arabia also increased significantly maybe from over the period. And in total, it's increased about from 1,500 million tons in 2050 to around 5,000 million tons in 2060 for the whole region. And some highlights from the baseline scenario is thus we can see that the massive increase in total material extraction in West Asia, especially in Saudi Arabia, to support the economic and population growth. And also we see that the extraction of non-metallic mineral, especially metal, increased substantially, and also it results in high growth rate of greenhouse gas emission. These outcomes will result in substantial stress on resource supply system and water management system and unprecedented level of environmental pressure and impact if we do nothing. So if we just leave the region and individual country in West Asia just develop as they are at the beginning as usual without any intervenes, this will be produce like unsustainable consumption and production system, and this will be harmful to the environment. So that's why in this study, in here we introduce the resource efficiency policy and climate mitigation policy, and also combine two of them to make the two of sustainability scenario. So the impact in this figure, I would like to show you the impact on material attraction in whole West Asia in aggregate level. Uh, as you can see, that's the two was the resource efficiency with the increased productivity in using and producing material will reduce significantly the material attraction or material demand in the region. But for the climate mitigation policy scenario, because we don't impose any efficiencies in using and producing material, and also not impose the production tax on producing or supplying material. That's why we can see that if only the material only reduced slightly compared to the baseline, and when two of them combine in the two sustainability, we experience about 40% reduction of the material extraction into our city compared to the baseline. And also, in civilized, I also would to show you the impact on material productivity over three different policy scenarios. Just we can measure in the real GDP per material input in the whole West Asia, and you can see that the productivities in the two sustainability uh, significantly increase when we compare the two policy, and for the resource efficiency actually is a very good um, outcome because it helps to use the resource more efficient and effectively to the input amount to produce the same amount of output with less input. And in this slide, I would like to show you the impact on material addressed by different countries in West Asia. For example, for the in the resource efficiency policy, thus different country compared to the baseline, for example, Saudi Arabia reduced by 40, 43.5% in 2060 compared to the baseline. And also in Jordan, also reduced the material demand by 36%. And the same thing is happening in for the material productivity by country in 2060. In Saudi Arabia is significantly improved for the resource efficiency scenario. It significantly improved like double the productivity, and also for Oman. And for this slide, here's you can see that for the impacts on the greenhouse gas emission for the whole West Asia in three different scenarios. And for the resource efficiency, actually it helps to reduce the material attraction or material demand, but it's inefficient to reduce the emission. By 2060, it's only we try to do about 20% of the emission level. But for the climate mitigation policy, and it's reduced by about 46% in 2060 because when we incorporate it, we impose the carbon tax on emission, and the industries try to reduce the demand for fossil fuel to reduce the burden, the financial burden on their emission. That's why in the climate mitigation policy is reduce significantly the greenhouse gas emission. And here an interesting for this result that we call it in the two was sustainability scenario. That's the real GDP of this country increased particularly for the UAEs and Saudi Arabia because the effects of the resource efficiency we incorporate to improve the productivity in these countries. But for most in all countries, the visibility in the region increased. So there are some highlights from the policy scenario that we we want to deliver from this study is that for the resource efficiency and climate mitigation policy compensates for each other. Lastly, for the first policy is try to reduce all categories of material extraction, improve resource use productivity, and also foster economic growth. But on the other hand, the climate mitigation policy had massive greenhouse gas emission and only slightly downgrade the West Asian economy, thus it will reduce the real GDP. And so when we combine the two policy package together and to implement in the region to make it to a sustainability scenario, we will come up with a win-win solution. Thus, we will have the lower emission level and material extraction, and we also experience higher economic growth rate. And in this study, we see that Saudi Arabia, Jordan, and Oman, um, in this country, material extraction rate reduced significantly by over 46% in 2060 compared to the baseline. And from this study, when we have the two policy package in hand, this means that we also have the well-being indicator grow faster than the resource extraction, which improve resource productivity and decoupling of well-being from resource use. So with the two policy package, we can have lower emission level, lower material demand, high economic growth rate, and that is the better for environment and contribute to tackle climate change on a global scale. So that's our presentation today. Thank you very much for your listening. Thank you.